All right, in this video here, we're going to talk about the definitions of radicals and roots. Right, so what a radical is like the fancy mathematical term for the square root symbol, which is probably something that you've seen before, right? This symbol up here, which we call the square root symbol, we call that a radical in mathematics, right? So this symbol here, the square root of a equals b, means that b squared equals a, and b is greater than or equal to 0. Right, so just to give you an example in numbers so that it makes sense, right? When I say that the square root of 36 equals 6, well, the square root of 36 equals 6 because 6 to the second power, 6 squared, equals 36, right? So the square root, or really any root that you take, is like the opposite or the inverse of raising something to a power. All right, so when I say the square root of 36, I'm thinking, well, what number squared gives me 36? And the answer is 6. Right, so the square root, again, is like the inverse or the opposite of a power, of an exponent. All right, which is why it's kind of put together usually with the laws of exponents. Usually you talk about radicals and roots not too long after that. All right, so again, square root of a equals b means that b squared equals a. Right, square root of 36 equals 6 means that 6 squared equals 36. Right, so that's the square root. Right, now we can extend that idea to what we call nth roots, where n can be any positive integer. Right, so it's most common for us to take square roots, and as you were coming up through school and through your math classes, through like middle school and like early algebra classes in high school, you probably use square roots quite a bit. But we can also take third roots and fourth roots and 17th roots if we wanted to. Right, we can take any positive integer as a root of a number. Right, so the definition of an nth root, and notice the mathematical symbol for an nth root, it has that same radical sign, that same square root symbol. It's just that n number, whatever root we're taking, we put that in that little nook of the square root symbol. Right, technically we call that the index number for the square root, or for the root. So that n is what we call the index number. It's not crucial that you know that terminology, index, but that's what it's called. Right, so the nth root of a equals b means that b raised to the nth power will equal a. Right, so like if I want to find the fifth root of some number, what I'm really asking is, well, what number raised to the fifth power is going to give me this thing that's underneath that radical sign? Right, so the n here, the root that you're taking, corresponds to the power that you have to raise some number to get this number that's underneath there. And whatever that base number is that you would raise to the power, that's what that root is equal to. All right, so to put a couple examples to it, just so hopefully it makes sense, if I talk about the third root of -8, right, so what number raised to the third power is going to give me -8? Well, that's -2, right, because if I do -2 raised to the third power, that equals -8. Right, what if I'm trying to find the fourth root of 81? Right, what that's asking me is, well, what number, when I raise it to the fourth power, gives me 81? And that number is 3, because as we see, 3 to the fourth power does actually equal 81. If you multiply 3 times 3 times 3 times 3, you end up with 81. Right, so the fourth root of 81 equals 3. One little thing that I skipped over here, when we're doing nth roots, if that n is an even number, so if I'm taking a square root, right, the square root means the second root, and 2 is an even number. Or if I'm doing the fourth root or any other even number root, the number that's underneath that radical sign has to be greater than or equal to 0, and my answer also has to be greater than or equal to 0. Right? When I'm doing odd roots, like for this one, the third root, I can take an odd root of a negative number, because when I take a negative number and raise it to an odd power, I can still get a negative answer. Right? But when I take a number and raise it to an even power, I never get a negative result from that. Right, which is why this rule is here. The a has to be greater than or equal to 0. Also, the b has to be greater than or equal to 0 when you're taking an even root. Right, for an odd root, it can be positive or negative. It doesn't really matter. All right, so that's the definition of what a root is. Again, one more time, just real quick. When I'm taking the nth root of a number, right, it's the opposite. It's the inverse of raising something to a power. So basically, if you think about this as like an exponent type problem, I have the answer here underneath the radical, I have the power here, and I'm looking for the base number. Or if I have the fourth root of 81, I know something raised to the fourth power gives me 81. I'm looking for that base that I need to raise to the fourth power, which turns out to be a 3, right? 3 to the fourth power equals 81. Right, so that's the meaning of radicals and roots. Hopefully that makes sense to you. sometimes it can get confusing, but if you recall that's all it is. It's just like a different way of formulating that relationship of that exponential relationship between those numbers, right? The roots are just kind of looking at it from a different perspective, right? But it's the same relationship between the numbers, 3, 4, and 81, just kind of written in a different way, right? That's all that roots really are.